Welcome to this explainer. Today, we're taking Python strings and transforming them from just basic blocks of text into a true craftsman's toolkit. Whether you're standardizing messy data, building rock-solid password verification, or honestly, even laying the groundwork for the next big search engine, getting a grip on string operations is absolutely crucial. So let's dive right in. Okay, so take a look at this complete mind map of string operations. Think of this as our visual syllabus for the explainer. Notice how the world of Python strings just branches out? We've got basic operations over here, precision string slicing over there, and then this massive, powerful ecosystem for testing, searching, and manipulating text. This map is going to make sure we don't get lost as we build up our technical toolkit. So here's our game plan. We're going to start with basic Python string operations, then move on to slicing and dicing strings. After that, we'll look at testing and searching text, and we'll wrap the whole thing up with modifying and splitting strings. All right, part one, basic Python string operations. This is all about laying the foundation. Let's start with the basic hand tools for accessing and combining characters. You can smoothly iterate over characters one by one using a for loop, or, if you need to, pinpoint them exactly using a numerical index. Think of a string like the name Juliet. If you throw a for loop at it, that loop runs exactly 6 times. The first time, it grabs the J, then the U, and so on. It's just a really fantastic automated way to evaluate text character by character, without even needing to know exactly where you are in the sequence. But hey, if you do need to know exactly where you are, that's where indexing comes in. Now, remember, counting in Python starts at 0. And here's a pro tip. Using negative indexes is an amazing shortcut to grab characters starting from the very end of your string. So say you've got the phrase, roses are red. Index 0 gives you that capital R. But if you just want the D at the very end, you don't have to count all the way up. No way. You just use -1. It's an incredibly efficient trick to navigate your data from back to front. Now, with great power comes great responsibility, right? The crucial thing here is using the built-in len function as your safety net. It absolutely saves you from the dreaded index error, which, let's face it, is a classic rite of passage for every coder where your loop just reaches a bit too far. Let's say you have the city, Boston, 6 characters. If you try to ask Python for index 6, assuming that's the last letter, well, Python's going to throw an index error right back at you because those indexes actually run from 0 to 5. Wrapping your string in the len function guarantees you always know your exact boundaries. Moving right along, let's talk concatenation. We can easily glue words together using the plus operator, or we can use plus equals to continuously append text to an existing variable. If you have the string hello and you add it to the string world using that plus sign, Python just seamlessly binds them into hello world. It's literally the digital equivalent of snapping 2 puzzle pieces together. But okay, here is a major plot twist for you when it comes to these basic operations. Can you actually alter the original string data once it's locked into memory? Like, if you have a variable holding the name Bill, can you just magically swap out the B for a J to make it Jill? Well, the answer is a hard no. Strings in Python are completely indestructible. They're immutable. And what that means is what looks like a modification operation actually just returns a shiny, brand new, separate copy of the string. So if you have a variable set to Carmen and you concatenate Brown onto the end of it, that original Carmen data, it hasn't changed at all. Instead, Python is quietly behind the scenes creating a brand new string, Carmen Brown, and putting it in a completely new slot of memory. Keeping this concept in mind is absolutely vital for keeping your programs bug-free. All right, let's step it up. Part 2, slicing and dicing strings. These are our precision cutting tools. Taking a slice of a string gives you a substring. And this isn't just theory. This is exactly how a university automatically generates a clever login ID by carving out specific pieces of a student's name and ID number. Imagine you've got a student named Amanda Spencer, and her ID number is ENG6721. By slicing out the first 3 letters of her first name, the first 3 of her last name, and then the final 3 characters of her ID, the back-end system cleanly builds her unique username, AMASPE721. So, the anatomy of a slice follows a very specific format inside those brackets. If you leave out the start index, it just defaults to 0. Leave out the end index, it defaults to the very end of the string. And adding a step value, that lets you skip letters like you're using a secret decoder ring. And what's really great about slicing? It's how forgiving Python is with it. If your ending index accidentally goes way, way past the actual length of the string, Python isn't going to crash on you. It just gracefully stops right at the end of the data. Moving into part 3, testing and searching text. Time to pull out the advanced diagnostic tools. Before we even touch any complex methods, you've got to know about the in and not in operators. They are hands down the absolute fastest way to verify if a smaller substring is hiding inside a larger string. If you're scanning the phrase 7 years ago, simply typing 7 followed by the word in and then your text variable will instantly evaluate to true. It's just an incredibly powerful and highly readable way to run quick diagnostics on massive blocks of text. And speaking of diagnostics, Python has these brilliant built-in testing methods that let you instantly check the exact nature of your text characters. You just attach these right to the end of your string variable. Say you need to know if a user accidentally typed a letter into a phone number field. Well, the isDigit method will instantly return false if literally anything other than numbers is detected. And these aren't just for show. These diagnostic methods represent real-world stakes. They are the exact mechanics used to validate if a new password is secure enough. Think about it. When you set up a new account online, the backend system is literally looping through your input. It checks the overall length with the len function, that it steps through every single character. If it finds one where isUpper is true, boom, a flag goes up. It does the exact same thing for isLower and isDigit. And if all of those flags aren't raised by the time it reaches the end, yep, your password gets rejected. It's that simple. Now, if you need to locate specific data or just swap words out entirely, searching tools like Find and Replace act as your automated proofreaders. For example, if you're writing a script to quickly sort files on your computer, the ends with method can instantly filter out anything that doesn't end with .txt. Meanwhile, Replace acts exactly like a global search and replace in a word processor, handing you back a perfectly edited, brand new copy of your string. And finally, part 4, modifying and splitting strings. Let's break out the heavy-duty power tools. Because we know strings are immutable, methods like lower, upper, and strip are fantastic because they hand you back freshly formatted, ultra-clean copies of your data. This makes them absolutely perfect for standardizing messy user input. Imagine asking a user to type Y or N to continue. By running whatever they input through the upper method first, you don't have to write code to check for both a lowercase y and an uppercase y. You just check the uppercase copy, which saves you both time and logic. Now, here's something kind of fun. It's fascinating to compare the concatenation plus sign with the repetition asterisk. The asterisk instantly scales and multiplies your text. If you've ever needed to quickly draw a divider line in a terminal output, you don't actually sit there and type 50 dashes. No way. You just tell Python to print a dash multiplied by 50, and it generates that repeating string in a fraction of a millisecond. And then we get to our ultimate structural tool, the split method. It elegantly chops sentences into lists of words separated by spaces, or it can slice apart massive data logs using a custom separator, like a slash. This right here is how you conquer large data sets. If you have a string reading 11/26/2018, you just call split, pass in a slash, and Python hands you back a clean, organized list with the month, day, and year completely separated out as individual items. It is literally the perfect bridge between unstructured text and structured data analysis. So as we wrap up this explainer, I want to leave you with this thought. How will you use these exact same foundational string mechanics to build your next great piece of software? Because every massive system out there, from Google's search algorithms parsing through your queries to apps securely verifying your login, they all rely heavily on these precise slicing, searching, and splitting tools that we've covered today. Master these, and you truly master the Craftsman's Toolkit. Thanks so much for hanging out with us, and keep building.